Hello and welcome back to another episode of Multi-Tech Spec. Today you're in for a good treat because today I've noticed that a lot of you like seeing my infrastructure projects, especially when it comes to networking. So today I've got a little bit of a treat for you because today I'm going to show you a couple of things, right? Because I thought to myself, what would be pretty cool? Well, I thought to myself, I know a little bit of networking. I know you guys love networking. You like my networking content. So I thought, why don't I build a little bit of a course around packet tracer and also some of the networking stuff which I have, right? I think that's kind of a good transition, right? Because a lot of you like seeing that. So I'm going to show you a couple of things, right? So this is a switch, right? This is one of them that I have, right? You've seen the other one, which is the 100 gig, which a lot of people I know love, especially around the AOC stuff. But let's get a little bit more kind of into the weeds of it, right? Because there's a lot of similarities between this switch and the switch which I have in my rack. But I wanted to kind of go through a few things to kind of help you if you're learning or if you're new to networking as to kind of how this works, right? So there's a couple of things, right? So if we look at the switch, we can notice that there's a couple of things here. I'm going to get rid of this because this is for the GUI and we don't really need that just now. Okay, that's just pretend I didn't have. It's not really relevant anyway, we don't really care for it. But, okay, cool. So, you see here, these are the LEDs, right? These are the LEDs for each port. So, for each port, right, which is on here, the RJ45s we call these are RJ45 ports. There's about, let's see, I think there's 24 on the switch. 2 blocks of 12, yeah, 24. So there's 24 different RJ45 ports. And this is the same as what you see on your Ethernet. So if you're starting out on networking, the thing that I want you to take away is that these are what you put your Ethernet jacks into when you need to connect multiple computers together, right? That's the kind of bread and butter basics when it comes to networking, is that all these really do is connect different things together, right? Because this is what a switch does, right? Like the light switch behind me, right? All it does is it converts the signal from a 0 to a 1. So if it's 0, it's off, the light switch is off. 1, if I turn the light switch on, turns the system on, right? In other words, information flows through it. And that's what these blinking lights represent, the voltages which go through the switch, okay? Now moving on, we have the GBIC in this case. So these are little SPF ports, but these are kind of the mini SPF versions, right? So that's called the small form factor, right? I believe it's called SPF, small. I'll look up what that means and type that down in here. But essentially, all you need to know is that these are for SPF ports, and then inside there's a little kind of cartridge system where you plug it in. And you've seen this before in my other videos, to be honest. So you don't really need to I don't really need to go into much detail about this, but you've seen it in the physical world, right? Now, this is a little bit of an older switch, and because of that, we have what's called the serial connector. Now, this is where you have your baud rate, you have your 9600, your 1, for example, for your bit, your flow rate, flow control, all of that good stuff. And the way that you do that is that you have a connector. I don't have one on me at this point in time, but I'll show you in the thing. Actually, give me a sec, let me go and find one. So I have one, so 1 second. Okay, so what that looks like is like this, right? So this is a serial to USB converter, okay? And this, I believe, is an RS-232. Yeah, it's an RS-232 connector. So RS-232 goes into here, right? Because this is the bit that you don't get to see on many courses. They don't tell you how to use real-life equipment. You get to use just packet tracer, right? In this series, we're going to be using real kit, right? I think I'm going to make the decision to use some real kit because you know, if we're going to be passing on this information to the next generation, not only do you need to know packet tracer, right, and GNS3 and all that good stuff, right? GNS3 especially in this new day and age with AI, GNS3 is a must. But at the same time, you need to know how to connect things together, right? Too many people come into the industry and they don't know how to connect things up. So I'm going to make my professors proud, right? if you're watching this and you've taught me how to do networking, I hope this makes you proud because I'm going to be showing how that's done, right? With some of the old Cisco gear that I've got. So this is going to be more exciting than what I thought in the first place. Okay, I'm actually doing it. Okay, but anybody who's following along, and if you don't have the kit, don't worry because this is going to prepare you for when you do get into the workplace as to kind of how to do certain things, right? That's going to be my aim for this particular series. Okay, so getting back to this, this is RS-232. This is called the pluggable. This is quite an old one because this has a driver which is installed onto the chip. And what does that mean? Well, because it's got a driver, you can see it inside of the Windows operating system, which means that it actually it's actually easier to interface with this, right, with the RS-232 than normal ones which don't have a driver. So if you're using any kind of special kind of things, you can do that with this very easy because it's reprogrammable. So, right, you see on this switch, if I go here, back to the RS-232 port, you'll see, although not very clearly, here we go, not very clearly, but it does say console, right? That's where we connect into the system. So what I'm going to do is I'm going to take this cable, and I'm literally just going to put it on here, but I realize that this is, see, a little bit of a problem. This can happen in industry, right? We have the same pinout on this side as we do on the console cable. Right, so what do we do in that situation? In this situation, what we need to do is we need to get a cable, which is an extender, which connects onto the RS-232 and connects also back onto the switch. And that will essentially connect on like this on both sides. And then this part, which is the USB side, will go into our computer in order for us to program the switch. Okay, and that's what we do. Now moving on to the back of the switch, we have, well, on this switch we don't have any kind of fans because I'll show you what that is, but we have the kind of free pong. This is a UK, sorry, not a UK, but this is a, and I forget the name because it's not a C19. This is a slightly different connector. But this one is a UK power plug, essentially. This is called a kettle lead port, right? So kettle lead port, which is kind of your standard everyday electronics, go into here, and then you power on the switch. It'll sound like a vacuum cleaner, but hey, it's a switch. That's what happens. Okay, moving on to the side now, right? On the side of the switch, you're going to have your fans, and these are where kind of the venting of the system will come through. So in other words, these will be like 9mm fans inside of here, and you know, some hobbyists will put Noctua fans in here to quiet down the noise. They'll put like 9mm fans in, and you know, this is kind of where all the noise comes from. Okay. Moving on, we've got your rack mount ears, right? So the rack mount ears on the system, this is what a lot of people don't go into, but essentially these are quite important because when you rack this on your 42U or your 19-inch rack, this is what's going to hold it together. So what you end up doing is getting your lug nuts and essentially lugging this and torquing it so that way it goes straight. So when you put it inside of the cabinet, it will look like that, right? Kind of level, yeah? And essentially, if you want to use this in a rack, you want a 19-inch rack. And the reason why you want a 19-inch rack is because, well, this is where it's going to be wide enough to put it in. But in this case, you want a bit of depth because, you know, this is kind of a full U or 1 unit worth of space within the cabinet. And when it has 1 unit worth of space, that's where you want to put this, essentially, right? It doesn't need to be so big. You just need to have not 1 unit worth of space, which is called 1U, okay? So that's the switch. Very, very cool bit of technology. And moving into our course, we have 2 different types of switches. One is called layer 2 switch. A layer 2 switch essentially doesn't have any routing ability. It doesn't really care for routes. It will just pass the data through and will do things like VLANs, STP, and will even do essentially basic switching, right? So VLANs, STP, VTP, those kind of protocols essentially, right? That's what this does, right? Particularly around VLANs in layer 2. Now a layer 3 switch combines routing capabilities like DHCP, BGP, OSPF, ERGRP, and those kind of protocols with the layer 2 abilities, right? So think of it as like a bit more of an advanced router, right? It's like a router, but just has many different ports. That's essentially a layer 3 switch. Nowadays, we're not too concerned about layer 2 and layer 3 now, because now we use more layer 7 application type facilities. So for example, Azure has their operating system, which allows you to install on different hardware like this, right? Different operating systems. So to kind of continue our course, each switch that you get has a particular type of operating system, right? Be it Cisco iOS, be it Juniper, Junos, which is Juniper's version, be it FortiOS, which is FortiGate, or SonicOS for Dell, right? For Dell Sonic Walls, right? They have all their own individual type of system, like the one which I have downstairs, which is, let me see if I can remember it. Oh gosh, how can I forget my own switch? But it is essentially it's a version of Cisco, and it's a very good one. Like you'll see it in the video, you'll see it in my other videos anyway. But that has a separate operating system as well, right? Now each individual operating system has different capabilities. So for example, if I was to go downstairs with that particular switch that I have downstairs, that switch allows me to do things like Ansible recognition with Python, right? So I can program it using Python or Ansible, because the libraries inside of that switch allow me to do so. Okay, it's a little bit more advanced. You don't really see this in a Cisco course. You see this more inside of the I'm trying to remember what it's called now. It's not Netacad. It is called Cisco DevNet. Yeah, in the Cisco DevNet courses, that's kind of where you see more of this, because if you're doing the Cisco DevNet tract, you'll see like the JSON, the Ansible, the Docker, all of that kind of stuff, right? That's where it fits into, because each switch has different capabilities. Now, if you're going into the data center, if you're going to somewhere like Azure, Google, if you're going into Microsoft, they all have blank switches, okay? They don't have operating systems. What your job is as a network administrator is to install the operating system onto the switch, and that will be like Sonic OS, I think, is what Azure has as well. Azure has like a Sonic version. I think it's called Azure Sonic, and that's their version that they'll be using for doing programmatic setup of the switch. So you might be thinking to yourself, okay, that's all very well and good, but how do you set a switch up? Now, when you first load up a switch, there's two ways that you can do it. Okay, one is via TFTP, and you download your operating system. Very slow, very boring, and I wouldn't recommend using TFTP if you can help it. If anything, PXE the damn thing, which is probably easier, because you can use HTTP as the actual protocol. But I don't know why. What's weird is that I don't understand why switches don't have that ability to PXE. It's a bit weird. I mean, if you're starting up from scratch, and you've got a metal as a service, right, which is basically what these boxes are, because there's no operating system in it, then why not just have the broadcast kind of pick up on, PXE, and basically say, right, okay, I'm going to be downloading this using some sort of answer file, which like is what you have in Windows. So in Windows you have an answer file, and in Linux you have a file. I can't remember what it's called in Linux, but you have a file in Linux which allows you to customize the operating system, essentially. But in kind of iOS land, in these kind of routing lands, I haven't seen anything like that, so it's a bit weird. Right, so when you have the TFTP server set, there we go. When you have the TFTP server set, you can actually then load up the boot image to put this in, and basically say, right, okay, this is loading up now, okay, within your fleet, because you're not going to be managing one switch, you're going to be managing many. Which comes back onto another part, which is that on some switches, this one doesn't have it, but on some switches, like my other switch downstairs, which is my Dell, it will have a stack cable at the back, right? You have a stack cable here. Not very common nowadays. Nowadays it's not very common. You won't really have a stack cable, because I think nowadays what they're doing is spine and leaf architecture, which means that you'll have like Kubernetes, you'll have a data plane and a control plane. Data plane being is where you route. Your control plane is where you kind of uh, have a controller which will control different things plugged into that controller essentially. So the data plane is just switching the data. The control plane is saying, I am the controller of this data. Okay, that's what generally happens in the spinal leaf design, right? You have one kind of master switch, if you like, and everything else is a slave, right? If you want to go into master-slave architecture, very old school, but basically that's what happens. Moving on, moving on. I think we've covered enough about switching a little bit. I think that's all good, except one last part that I want to kind of say is that this is your RJ45 cable. This is a copper cable. This is the one that you'll be working with most. It's at layer 1, which means physical layer. And essentially inside of this cable, there are 8 twisted pairs. That's following the TIA 5A and 5B standards, which is how you'll essentially cable this up, right? And that's like red, orange, that sort of thing, like red, orange, orange, white. We'll go into that in a little bit of detail, but essentially this is kind of the cable that you have, and then you'll say, right, okay, plug it into this slot here, like that, and then this goes into your computer, your firewall or whatever you want to plug it into, essentially. And within the Cisco exam, you used to have a facility on Cisco switches and other switches called Auto MDX, I think it's called. And Auto MDX kind of changes the layout of the switch of the cable to either become a straight through or a crossover cable. So what's a straight through cable? So if you imagine on this cable, right, there's cables inside of it. The way that these cables are arranged inside of this RJ45 cable is that they are kind of one-to-one. In other words, in here I can see we have brown, white, green, white, blue, white. So it's normally blue. It's like blue, white, and then we have orange, orange, white, right? And the way that these are arranged is that they go from one part, like this part here, which is the top part, to this part here, which is the bottom part, right? Down here. But rather than crossing over at certain sections, right, which would be a crossover cable, they are all straight, right? That's what I mean by straight through and crossover, right? So I hope that clears up a little bit of that. And if you go back to the switch just for one more second, you'll see. Does this have it? Yes, it does. Okay. So this is what's come out, but essentially, you'll see that there's link act, which is, if this will focus. Yeah, okay. Like link act here. I'll try and see if I can get this more in focus, but basically it says link act, and then you'll have gigabit, right? So on the switch, certain switches will have different speeds, different frequencies in which they can communicate information, right? Like the one downstairs on my one, which I can't remember the name for the life of me, which is really annoying, but is 100 gigabit per second, right? So that's 100 gigabits per second in terms of frequency in which data can be sent through. So in other words, we call this the bandwidth of the switch, right? This is the bandwidth because this is the capacity in which it can carry, right? So capacity, the way to think about capacity, think about a highway, right? If you're in America, it's a highway. If you're in England, it's a motorway, right? 12-lane highway, 12-lane motorway. That's the capacity in which your switch can deal. That's the capacity in which your switch has. Now, the throughput is essentially the frequency in which you transmit the data. So you can have like 100 cars on it, right? And that will be your throughput, right? So that's as fast as it can. That's as many cars as it can have on that particular highway. Okay, good way to think about it. Right. Okay. Cool. So that leads us into TX and RX. So if you see a switch and it says TX and RX, TX means transmitting the data. RX means receiving the data. Now, why is that important? Because when you look at the switch in the real world, okay, forget the course for a second, but if you look at it in the real world, this is what's going to tell you if the switch is working. Because if it blinks, that light blinks of TX and RX, you know it's receiving data and transmitting data, which helps you in your debugging phase. Yeah? That helps you in your debugging phase, because now you know what the switch is doing. If the light is static on a switch, right, that can indicate many different things, like system memory allocation failures, right? That's to do with memory addressing. So inside of the switch, if you have a certain amount of memory and the memory is filling up the buffer, you end up in something called a buffer overflow, right? Which means that you have memory leakage now, right? Which will cause, yeah, so it will cause system memory allocation failure because you've got more data coming in than the switch can actually receive and process, okay? Switches are kind of slow. A lot of modern switches are quite fast nowadays. You can go up to 800 gigabits per second. I'm pretty sure we'll see 1.6 terabit per second switches, okay? So, yeah, that's TX and RX. And then the other debugging step that I wanted to process was, yeah, you can have things like STP looping, which can cause flooding within the switch, which can lead to the light being on all the time. And then the other one is broadcast storms. Broadcast storms essentially where you have a broadcast, a lot of frames coming out, which is at layer 2, and essentially, it's like me shouting with everybody in the room shouting at the same time. That's a broadcast whereby nobody gets a word in. Okay. Now there are mechanisms inside the switch to prevent such things. So, for example, inside of the switch, there's something called CSMA/CD, called Carrier Sense Multiple Access / Collision Detection and Collision Avoidance Systems, where there are certain timers within the switch whereby, if I'm speaking, for example, okay, as a listener, you listen, and then you participate by speaking back, right? That's essentially CSMA/CD. Sorry, CSMA/CA. CD is the collision detection. So if I'm speaking and somebody else is speaking, that's a collision being detected, right? Whereby a backoff timer is then ensued, right? I think it's about 30 seconds, whereby you then say, right, okay, I'm not talking, you're not talking, can I talk? I'm going to try and talk. If I detect that you're talking, I'm going to shut up, you're going to shut up, and let's try this again, okay? That's basically what's going to happen. So that's part of the mitigation. In terms of the broadcasting, the way that you mitigate against that is through VLANs, the STP problem, so in other words, the STP frame going around in circles. You have TTL, which is called time to live. That gets decremented by 1 every time that the frame moves between the bridges, but that's kind of a temporary fix because it's through each hop. So what I mean by hop is like you go from, it's like hopping, right? Like in hopscotch, right? You go from 1 to 2 and then, back to 1 again and then, that kind of thing. But essentially you're moving from one place to another. That's called a hop. Yeah. So with that, once that's done, it goes through, the frame itself should tire out because that's one of the ways in which it tires out. In other words, it becomes 0 and the time to live will become 0 in the frame, but through the detriment. And then as that's happening, the frame will essentially no longer be, it won't go anywhere because it's got nowhere to go. The frame is dead. But we'll look into that in a bit more detail. But the best way to get around the STP problem is essentially to set the root bridge, right? And make sure that both ports to the root bridge, right, are in blocking state, or one is in blocking state, one is in the alternative state. In other words, able to become the new root bridge in the event that it collapses. And that's set via the BPDU. And inside of the BPDU, that's the MAC address and the spelling tree number, right, of the VLAN. Okay, cool. So we've talked a little bit about STP here as well, which is great. Yeah, that's basically the mitigation. Okay, let's move on, shall we? So, moving on, let's go to display 2. And here we have Packet Tracer. Packet Tracer is what we're going to be using to learn the kind of theory, before we get into learning the fact on the real equipment. So, depending on your operating system, right, what you want to do is you want to go to this URL, so I'll zoom in on this URL, which is www.netacad.com/resources/lab/downloads courselang ENUS if you're in England or in the USA or in an English-speaking country. But what you want to click on is you want to click on the Windows one, which is Windows x64, or if you're running in Ubuntu or Mac, use the Ubuntu or Mac one as you want. Or if you're doing cybersecurity, download the Cybersecurity Essentials VMs, okay? Depending on your track. So there's many different tracks within the Cisco Network Academy, the NetAcad. This is the new version. I've not been enrolled in this particular version. I just had to enroll myself because when I was studying Cisco, man, was it different. It was very different. You can talk to my instructors to see that, but man, it was different before, right? Okay, cool. So once you've downloaded it, you'll be asked to sign in, right? Now, what you'll get is a screen like this. And what I like to do is click on Networking Academy. I'm going to log in with Google, so you get this screen here. Okay. I'm going to log in with Google. I'm going to log in with my Google address. Okay. I'm going to enter in my password. Do my two-step verification. Sorry. Two-step verification. There we go. Yes, it's me. Okay, and I should now be able to use Cisco iOS. Okay, I've got to put in a few things to get that through. So just answer a couple of questions. Create my account. Okay, and now I'll be logged in. I'm enrolled. So I should now be able to, please refresh your browser to see updated status. So I'm enrolled. It says I'm enrolled. I should be able now to use iOS, which it now is shutting down. That's really annoying. Try this again. Oh, it's not keeping me logged in. Okay, so you need to click keep me logged in, and now we're going to try this again. I'm going to put this in. Okay, log in with Google. 214@gmail.com. Okay, type in my password. Let's do my two-factor authentication again. Okay, is this doing it? Clicked on confirm. Okay, let's resend it. Sometimes Cisco iOS is a little bit funny with credentials. I'm not sure why. Okay, there we go. It's giving me a message. I'm gonna click yes. Okay, cool, and we're in. So what you'll get now is you'll get Packet Tracer. Okay, you get Packet Tracer like this. Now I'm on a 4K display. And on the 4K display, I can't see anything. My goodness, this is really bad. I'm not sure what Cisco was trying to do here when they, tried this, but yeah, this is bad. I can't really see anything. Right, let's see if we can zoom in or something. Zoom in? Nope. Okay, so I'm not sure exactly what's going on here because I can't see anything. Okay, rather than worry about that, let's kind of look at some of these options that we have here, right? So we've got a number of different Cisco kind of equipment. So I've got a 2901 myself, and I've got a 33 series switch, which is not here. So unfortunately, they don't have the series that I have, but that's fine. It'll still work. You've got hubs, you've got wireless devices, security, WAN emulation. So that's kind of like if you want ISP level. But for CCNA level, this is fine. So what we can do is we can say, right, here's our router. So router is there. We can have our switch, another switch, and we could say, right, why don't we have a end device, right? So like a PC, another PC, another PC, right? Okay. Okay. So in Packet Tracer, you don't have to worry about setting things up, right? Because in real life, you kind of do, right? You're gonna have like the router there, you're gonna have the switch there, then you have the PCs. Make sure that they're on, make all of that stuff. So you can kind of emulate it within Cisco iOS, but it's not the kind of same thing because this isn't really how we would do things in industry, right? There's just no way you would do this in industry. But I want to make note that when you click on the router, you get different types of modules, right? So you can have the WIC 2T, for example, which is a staple of some older labs, but you can have it, the Shield, the SFP module for fiber optics, and that sort of thing, right? So now, we have a very basic network here, right? So this is a very basic network if we were to link it all up. So, what can we do here, right? What's the sort of things that we can do? Well, first of all, we need to understand that there are 4 computers here, right? 4 computers. So if we have a big subnet, let's say, for example, our team lead, he goes in and he says, there should be a thing around here to put, oh, right, yeah, so here's some of the other things as well, right? So you select your text, this is where you put notes, your draw a line, rectangle, ellipse, freeform, simple PDU, complex PDU. But let's go to add a note. Okay, and we'll say, say our team lead says 192.168.1.0/24 as our subnet. Okay. And he says, right, we need you to subnet that out. So that way you've got, group of, let's say, 16 hosts, right? So 16 hosts. Okay. So 16 hosts, fairly easy because we already know that with 24 you have 256. How do we know that? Well, you have octets. Now each octet within a subnet, right, because this is a subnetting section now, is going to be 8 bits long, right? So we have 2 to the power of 32 bits that any IPv4 address can be, right? So you have 32 bits if they are all on, right? There'll be 32 bits. So what would that look like? So it looks like 4 groups of 8. So if we have 1, 2, 3, 4, 5, 6, 7, 8 dot, right? The dot is a representation of 1 octet. So this is the next part, right? The next octet. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay. Basically, that's what it looks like as a completely off state, right? All zeros, nothing in there, right? Because it's binary, right? So what's all binary ones? 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's all off, that's all on. Right? In programming, a 0 and a 1 in this state is called a Boolean value, right? Boolean being true or false, okay? In programming. But in the Cisco iOS world, in other words, the networking world, in networking, each value of the 1 inside of each octet represents a numerical value in base 10, which means in mathematics, right, this is a number. Okay, this is a number. And that number, when everything is on, is representative of 2 to the power 32. Okay, because there are 32 bits, right, 32 bits which are on. So each one of these, like 0 is a bit, 1 is a bit, right? Because these are the placements, right? So that's 1 bit, that's another bit, another bit, another bit, another bit, another bit, right? Okay, cool. With me so far? And that's a little bit hard to believe, right? but 8 bits to a byte. So these are 4 bytes long, okay, because they are 8 bits to a byte, which means it's 32 bits long, which is where we get 32 from, okay, in an IPv4. And this is representative of an IPv4 address. Okay? So the value that you have here, right, when all bits are on, is 4 million. In fact, let me check this. So 2 to the power 32 is a result of this many IP addresses. This is how many you can have in IPv4 space. Okay? 4 billion, I think it's 4,292, 4,294,967,296, right? That's how many you can have. Okay? Cool, so that's 2 to the power 32. Okay, so we have 16 hosts. Okay? So we need to divide our bits up. So what does that mean? 16 hosts. Okay, so it means that in this particular IP address, right, because you have host bits and you have network bits, right, if we look at our octet, right, what we can do is that we have /24. /24 is our subnet mask, okay? What does that mean? It means that 24 of these bits are on, okay? So what does that mean? It means that with /24, you get, right, network bits, the 24 network bits. So that means that 1, 2, 3, 4, 5, 6, 7, 8 dot 1 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot not is on, because each one of these ones are representative of the network portion of the address, the network part, the network bits, which are on. Okay, but there are no host bits which are on, and we're looking for 16 hosts. Okay, so what do? Well, we have to work backwards, right? Because, right, it goes from 2 to the 7 to 2 to the 1, 2 to the 0, sorry, not 2 to the 1, right? That's the array of the numbers which we have. So that means, right, if we have, 1, 2, 3, 4, if we have 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, dot 1, right, that's going to be 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4, and not, right? Because, why is that not? I'll show that in a minute. Okay? So, the reason why is because, right, 2 to the 7, 2 to the power 7 equals 128. 2 to the 6 is 64. 2 to the 5, 32. Right? Two to the 4 is 16. 2 to the 3 is 8. 2 to the 2, 4. Oops. 2 to the 2, 2. Power 2 equals 4. 2 to the 1 is 2. And 2 to the 0 is 1. Yeah? So in all of those numbers, right, because we have 0 as being, our network bit, which is on. So in other words, there's no network, there's no network bits on in the 4th octet, right? Where do you think the 16 is going to be now? That's right, with the 4th bit on. So if the 4th bit is on, right, our new host address, the new network portion of the address, is going to have 4 bits on, and the host part is going to have 4 bits off. This is now indicative of our subnet. In other words, where our subnet is going to, the last number in the subnet, in the starting sequence of the subnet. So, in this case, it's 192.168.1.0, okay, going into 192.168.16 as the new subnet. Okay? Because in the new subnet, the new number, which is the network portion, is going to be 16. Okay? So what does that look like? It's going to be 192.168.1.0/24 as our first network. Okay? Our second network we know to be 192.168.1.16. Okay, /24. Okay. As a new network, it's going to be 16. It's going to be still /24. That hasn't changed. Okay. It's just that this portion of the address has changed. The subnet mask hasn't really changed. Okay. We know that, and that means that that's going to be the second network. Okay, that's going to be the second network. And let me just double check this. It's going to be /24. No, it's going to be 28. 28. Okay, yeah, that's going to be 28 actually. Okay. Let's change this. Okay, well, let me change it. Nice. Okay, cool. This is going to be our second network. All right, because we no longer have access to 256, so that makes no sense. It's going to be /28 as our next network. Okay. Why? Because we added those 4 bits in the network, to the network portion. So if we added those 4 bits to the network portion, that means that the network portion has to now expand to accommodate those extra bits, which means that that length is going to be 28. It's not going to be 24 as it was before. That's the reason why we added. That's the reason why that mask is now 28 rather than 24. Okay. And that's representative of the second network. Okay. Now, what's in between the first network and the second network? Well, it's going to be 15 different addresses, right? So our first number that we can use and assign to each host, okay, is going to be 192.168.1.1. Okay. Okay, that's going to be the first one. And the last one is going to be 192.168 slash 1.15, right? And it's not going to be 15, right? Because there's one more number, which is 192.168.1.14. Why have I said that? Because this is our first usable address, okay? And this is our broadcast address. Oh, hello. Broadcast address, right? Which means that our last usable address is 14. Right. So now that we know that, it means that we can assign each value in the network to each host. Okay? So, let's get to it. Right? We know that there's four computers within the network. Right? We know that the last one's going to be /28, 16 bits on. Everything after that is /28. So in this case, it's going to be /28. Okay? /28 is our network, our new network. And that continues on because, remember, the network portion is 16 hosts long. Not 16 network, not 16 in terms of the network part, it's the amount of hosts, right? 4 bits was the network, right? We added 4 bits to the original network to give us /28, okay? That's why it's 28 going all the way down, okay? Because each new network is going to be 28 bits long, okay? So when we go to our next network, it's going to be /32, sorry, it's going to be 32/28, 64, right? So on and so forth, because each increment is 16, is of value 16, okay? Each increment, Okay. In this case, that's exactly what we've done. That's why we have /28 as the network network mask, essentially the CIDR mask. Okay, our CIDR. Okay, cool. So let's assign that, and let's go in a little bit further with our course. We're going to be using straight through cables because that's what we need. And we're going to go to fast Ethernet, and on this switch it's going to be fast Ethernet. So this is 100 meg. This is only going to be a 100 meg network. Okay, we go in there, and let's link this all up. Number 1, we'll go number 2, like so. Okay, and then we're going to have gigabit in, and what we can do, because I think this is a crossover cable. I'm pretty sure it's a crossover cable, but we'll double check. Cable does not go in that port. No, it's a straight through. Fine. Straight through. Straight through. Come on. There we go. Okay. What's going on here? Why is the router going up to the switch and it's red? Why is it red? Right. The reason why it's red is because it's not on. That's one of the reasons. So let's click on the router and let's check that it's on. So the way that you do that is you double click, and we're going to just click on it. It opens up in my main display, so you can't see it. Okay, cool. And it's so small I can barely see it, so let's zoom in. Okay, so it's on. It's on. Well, how can this be? How can it be on, but yet there's nothing there? What's going on? What's going mad? What's going on? Okay, calm down. Calm down. First thing is, are the ports on? Right, let's do a bit of troubleshooting. Let's figure out what's going on, right? So what do we need to do? Well, first of all, we need to go into our CLI, right? For now, we're going to negate security. In the real world, we wouldn't. Okay, we wouldn't negate security. For now, because we're learning, we're going to negate security. So let's go into our CLI. This is called the Cisco iOS. And we don't need to do any other configuration for now. What we're going to do is going to say no to this. We're going to click enter. Okay. Now comes our commands. We've got the router here. Let's type in en, which means enable. Conft, which means configure terminal. And what we're going to do is we're going to do something called a do show run. Okay. Why am I doing a do show run, right? Because with a do show run at this level, you can see what the running configuration is. Now, if you're in an exam situation, you wouldn't go from here. You'd go from exit out, and you go to this level, which is the this is called privilege execution level. Okay, you have different levels. You have the configuration terminal level, which is the config level. This is where you have kind of more access to the router. You have the privilege level, privilege execution level. Okay. So let's do a show run. And you can see that there's nothing inside of this system. There's completely blank configurations, which is good. So what do we do now? So let's drop a level. Let's go to configure terminal, conft. And what we're going to do is we're going to see if the interfaces are up. So let's do a show IP int brief. We'll do that at the next level, as in the level up. Show IP int brief. And you can see that, well, all of our networks are down. In other words, all the links which are on the router are down, right? They're down by design. So what do we do to bring them up? Well, first of all, we need to say that they are up to begin with. Okay? So let's do that. Let's do a conft. Let's do an interface. Let's see which interface is connected. We see all of them down. So we've only got 2 interfaces, so that's pretty easy. Let's bring them both up. INT, and we've got gigabit and fast Ethernet, right? But this looks like a gigabit one. So let's do a gigabit. So gigabit 01, and I just did tab completion to essentially go up. So in other words, to complete the system, and we'll do a no shut. Okay. Now what we'll see is one link has come online. Okay. Switch is doing its calculations. to figure out what the link speed needs to be, and then it will link up with the switch. And now let's go to the side. So we'll do int gigabit. Let's do a gigabit. That is right. Yeah, that is right. Let's see, nothing. Okay, int gigabit. Okay, int gig. Oh, it's configuration if. Right. Okay. Sorry, that's my mistake. So config if means configuration of an interface. Okay, this is where we do things like program the IP address. That's the reason why that command wasn't working. So what we do is we do an exit, go back. You can do up completion. So in other words, up arrow again. Go to 0, 2. This is that we don't have it, so we'll do 0, 0. No shut and no shut. Okay, which means no shutdown. And now we can see it's up. What we'll do at this level is exit out again, and we'll do a copy running config, startup config. Okay, so when it starts up, there we go. So when it starts up, the system will then remember the configuration and start up with the configuration that we have, right? It will store that configuration within the NVRAM, which means non-volatile random access memory. So if you think about having a stick of RAM inside of your computer, right, as a little DIMM, right, it's a DIMM slot inside of the router, that's what's happening. It's going into the memory, and it's staying there, right? Volatile memory in system architecture means that when you turn off the system, the memory is erased. Non-volatile means that when the system is turned off, the configuration that the system had will always remain in the memory, okay? That's basically what that means. All right, cool. So now you're thinking, oh, yes, this is working, right? Cool. I mean, surely I should be able to ping the router now, right? Come on. Come on. We spent an hour. This should work now, right? Watch this. Watch this. So if we go into the PC0, I've got to bring it over from my other screen. Okay. Right, I go in from my other screen. Let's go to desktop. I want the desktop configuration, but it's going to come from terminal command prompt. You know, and I do an IP config. What? Nothing. Nothing. Oh dear, that's confusing, right? That's not good. That's not good. What can we do now? I mean, didn't we just build a network? Didn't we just like figure stuff out? Sadly, it doesn't work like that. We've got to assign the IP addresses. And now there's two ways that we can do this. One is through DHCP, right, called Dynamic Configuration Host Protocol, which is where the router gives out IP addresses to the PCs. And the other one is, well, static IP addressing. So we have some IP addresses. Okay, we kind of know what the IP addresses are going to be based upon our subnet. So why don't we see if our subnet is correct, right? Because our team lead has given us the subnet. And let's see if we can do an IP address on. Let's see if we can do an IP address to see if our IP addressing is correct, right? So we already have two subnets, right? Subnet 0 and subnet 1. Subnet 0 is our main kind of subnet. In other words, this is the subnet which we start with, which is going to be 192.168.0/1/28 in this case. And let's see if we can communicate with that IP address, right? So what can we do? So we can say within our IP configuration, we can do a static config, and let's give our router the first IP address, right, on one of the interfaces, and let's give our PC one of the other interfaces that we can use, right? Sorry, one of the other IP addresses that we can use. So we'll say it's 192.168.1.2, right? Subnet mask is going to be, okay, it's going to be 28. So we need to add those 4 bits together, right? Which is going to be down here, invalid subnet. Yes, we know. Let's go down here. Let's do 128. We're going to do 64. We're going to do 32. 16. Okay. and it's going to be 192.224.240, right? 240 is the IP, is the subnet mask. Okay, 240. So go to desktop, IP configuration, 192.168.8.1.1. Sorry, 1.2. And we're going to use 240 as our IP address. Default gateway is going to be 192.168.1.1. How did I get that? Well, that is our IP address for the router. And the router is going to be our default gateway to things like the internet. And that's generally what happens. It's our gateway to the internet. And that's why it's called default gateway, right? Because you have a default route or an IP address or BGP, which goes over to the internet, right? The next available network, essentially. Okay. Okay, cool. That looks good. And we're going to exit out of that. Invalid gateway address. Invalid gateway address. Why is it invalid? Ah, right. Okay, because it's on 60. Right. Okay. Yeah. Okay. Okay. It's not valid for the first network. It's valid for the second. Okay, I got it. Got it. Got it. Got it. Got it. Okay. Okay. All right. So essentially, we are on 17. No, 16 is. Oh, okay. Yeah, 17 is going to be. Right. Okay. It's 17. It's 17. This is actually 17. 17. That's what this is. So this should be fine, I think. 192.168.1. 16 is on network address, so this is going to be 18 actually. Yeah, I know. 18. 18, that's what it is. 192.168.1.17 is going to be our subnet mask. That should be fine now. Yes, it's fine. All right. What happened there? Why did that not work? Because when we moved our network, right, our actual subnet mask isn't 1.1, it's actually 16 because it's the next subnet. So actually what it is actually 16. This is 16, and this is going to be not 1, but 17, because our actual network, the first network, is not 0. It's actually 16 is our subnet, right? Subnet, next usable IP is 17. Last usable is going to be 31. Broadcast 32. Sorry, 31 is our IP. I'm jumping ahead of myself. 30 is the last usable IP. 31 is our broadcast. 32 is our second network. That's what it is. That's what it is. Okay? Because we changed the network bit to incorporate the new network. So our new this is our new network. Okay? Incorporating the the 16 hosts. New 16 host network. Okay? Cool. This is technically called VLSM, or variable subnet masks, when we incorporate hosts. When we do subnetting, we don't go into this much granular detail. We go from the next network and then put the next network in, and the next network, and the next network. But that's just not how it works in real life. So I'm teaching you the real life version of this. Okay? And let's go to network. Okay, now that we know what our IP address is for this particular system, we can do a conf-t. And it's going to do our TFTP translation. So in this particular situation, we need to do a Control-Shift-C or Control-C to break out of that. Control-C, if it will let me. And it won't. I'm going to let that just simmer down for a little bit. And I'm going to go to the next computer. And we're going to do 192.168.16.18. And subnet mask is going to be the same, /240. And default mask is going to be 192.168.16.17. Okay, and I believe that's correct now. Okay, cool. That's good. Let's go back to our router. And Control-Shift-C should do it, but it's not allowing me. It's just recording some stupid clips. I don't know why. Control-C. So normally Control-C should... There we go. So unable to find it, which is good. And we're going to go and do a conf-t. Hello? Conf-t. We're going to do a show IP int br. Oh, exit out of that. Okay, now we'll do a show IP int br. Show IP int br. There you go, better. So we've got gigabit Ethernet 00, so int gigabit, sorry, conf-t, int gigabit 00. Okay, and we're going to do an IP address, and we're going to do IP header, which is 192.168.16.17. 245.245.240. No shut. Prospectus, we've already no shutted it, but it's fine. And now, if we go back to our PC, and let's go to our command prompt, do an ipconfig. Let's check. That looks good. And now we'll do a ping to our router, which is on 16/17. Let's see if it works. I've said 117. That's incorrect. It's not 117. It's 16/17. Let's do 16/17. Our default gateway. Desktop. Let's check ipconfig. 16/17. Interesting. So it's still not finding it. Let's check. Let's check. What's going on here? What's going on? Why are we not getting a signal? (16/17) set /240. Check our command prompt. We're seeing 100% packet loss. We're seeing 16/17. Same 240 network. Oh, can you see the problem? Can we see the problem here? Chat, can we see the problem? Right. What's the problem? What's the problem? Okay, this is part of it. What's the problem here? I do an ipconfig. What's the problem? I'm going to give 5 seconds. 5, 4, 3, 2, 1. Okay, cool. So you see that IP address that I put in here for the system. You see how it says 192.168.1.18? Right? That's referring to a different subnet. In fact, that's an entirely different network. Yeah? Because, actually, that's incorrect as well. I just realized. That's actually the correct subnet, and my default gateway is actually wrong. It should actually be 1. Right? Why? Because he said it was 1 before. So I actually mixed up the octets. That was the problem. But good learning experience, because in the real world that can happen. Right? So now that's on the correct network. Okay, so this should be correct. Let's double check. Let's do an ipconfig. 1.1. Yep, that looks good. Let's check the other side. And let's go to our command prompt. And we have made the same error here. It's 117. And let's go back to our IP configuration. 118. Let's go back to command prompt, ipconfig, and it's not added in the values. Okay, that's not good. 117. It's still not added in the values. That's weird. Because it's written it off. Okay, 192.168 .1.17. Sorry, 1.18. IP address is already used in network. Okay, so it should be 118 is already used. So 119. Okay. 68.1.19. 168.119/240. Okay, there we go. 192.168.1.19. 240. 17. Looks good. Looks good. And we'll do a command prompt just to be sure. 19 looks good. Okay, and now we need to check our router. And we're going to be doing not 16 like this. This will be 117, 130, 131, 132. That's exactly correct. Okay, and we're going to change this IP address to be 117. No shut. We're going to do exit out of that. We're going to exit out of this, and we're going to do a copy run start. Copy run start. Okay, there we go. Now let's try. Command prompt. Ping 117. And there we go. There we go. We've got connectivity. That's basically it, right? That's how we set up a basic, very, very basic network. Very, very basic network. We've done our subnetting. We've done our routing, okay? And we've even done our part in there, right? So we've even done our configuration on our interfaces, made a basic network. We've done our networking. We've explained a little bit about switching as well, real-life switching. And yeah, that's it for lesson number 1. Hope you've enjoyed. Hope to see you again soon.